it's time to start taking a look at different types of graphs. Now when I'm talking graphs here, I'm talking specifically about one type of data. Quantitative data. That is numeric, not just numeric though, it's measurable. We're talking about different ways that we can graph measurable data. All right, so some of these are probably things that you've done in the past. Some of them are going to be a little bit new to you. No worries. We're going to talk about some of their similarities, about some of their differences, go through, in many cases, how to create them, how to construct them, whether by hand or on a graphing calculator. On the upside, for most of the AP exam, much of what you have to do is interpreting graphs more so than creating graphs. There are exceptions, don't get me wrong, but for the most part, that's what we're looking at doing. Types of graphs. First type of graph is one of the more, I don't know, call it simplistic, just a dot plot. So if we had a bunch of data about people's heart rates, and most people measure their heart rates in actual values, so 60 beats per minute, and then this would be 61, 2, 3, 4, 5, 6, 7, 8, 9, 70. We'll just assume that this is all we have. A dot plot is very simply saying, oh, someone had a heart rate of 70. So we take and we make a dot. And then we had someone who had a heart rate of 65. And maybe we had 3 of them. So we stack those 3 dots up. And maybe really 70, we probably had more like 5. What I want you to look at, though, is that this dot we have lined up with this dot. So they are across from one another. So if I have 3 dots, they are at the same height. I do not want to take all of these dots and compress them down to the same height as these 3. The reason why is when we do comparison of the graphs, we want to see how 65 compares to 70. Alright, so that's just simple dot plot. Next up, we have our stem plot. So here's a set of data of just some fictitious heart rates that I made up just a moment ago. Alright, to make a stem plot consists of 2 pieces. Over here we have our stems, and over here we have our leaves, where each one is a leaf. The stems are arranged numerically from lowest number down to highest number. So when we're looking at this data, I have stems. Now really when we're looking at this, a lot of times you're talking like decimal places or tens units, ones units, hundreds units, etc. If I were to do this set of data, I would probably do my stems in 2 ways. I would probably have my stems like this, 2 6-stems and 1 7-stem. There are more than those different ways to do them, but that's how I would do it, and I'll explain why here quickly. Right here, I'm going to have the low 60s. Here I'm going to have the high 60s. So really here I have 60 through 64. Which means here I have 65 to 69, and then here I'd have 70 to 74. 5 each. You got to have them equal. But then what I do is I go in and I add in, okay, so I have 60, and I have to do them in order from lowest to highest. 60, 61. There are no 62s. There's 63, 63. There's no 64s. And then now I'm down to the next column, or excuse me, the next row. And then I go, okay, over here, so I've done 60, 60, 61, 63, 63. Next up is 66. So I have 66, 67, 68, 68, 69, 70, 70. So in each of these, if I were to pull out 2 values, this and this, that represents the number 68. Now again, just like we did in the dot plot, make sure that these values are lined up vertically, so that way we can compare and look to see, oh, this row of 60 and this row of 60 have about the same number in them, fairly evenly distributed in those 2 values. There are other ways to do the stem plot. We're going to try several, so don't worry, that's just one. The big 2 that's my term, in terms of the two graphs that we use very often and we will see very often are the histogram and a box plot. All right. Again, both are used for finding quantitative data, and you've probably seen histograms before. These different bars that go up and down. All right, and when you've seen them in the past, you've hopefully recognized that these intervals down here are all the same width, or they should be. If they're not, you have a fairly misleading graph. And down here, my x variable is whatever it is that's being, again, measured. Quantitative, a measurable value. All right, and then the height for these bars tells me how many are in that range. The range from this point to this point. How many actual measured values of x are in this range, and that's this number up here. Histogram. Box plot. If you've seen it before, they look something like this. In terms of shape and structure, in terms of structure, they're all the same. In terms of shape, they might be different. All right. So what I have is this value down here is the minimum number. So in my previous example, 60. This over here is 65. This value is the median, or the 50th percentile. If I line them all up, lowest to highest, that middle number, the median value, is this bar. All right, so I need to have a scale down here for whatever my x values are. And here it's going to tell me how condensed my data is, say, in this range. Okay. So again, this is the median. This is the 75th percentile, right here at the end of the box, which means 75% of the data is at or below. So from here to here, if we look at all the data points that are on this line of the actual data set, 75% of them are below this value, which makes this the 25th percentile. Now these have special names. This is Q1. This is Q3 for the first quartile and the third quartile. We almost always call this the median, however you can refer to it as Q2. This is called the minimum, but it is technically Q0. How much data is at or below the minimum? Well, none, so that's why it's the 0th percentile. And this is Q4 for the fourth quartile, or if you have 4 quarters, you have a whole dollar, or 100% is at or below that value. That's the real basics of what those things are. We'll talk about constructing them. We'll do many in class. Interpreting them is what we're going to do soon thereafter. But this is just getting you an introduction to constructing these different types of quantitative graphs.